Okay, let's dive into this. We are standing literally on the edge of a monumental shift in technology. For decades, our entire digital world has relied on painstakingly writing out manual lines of code. And we've all been there, right, where a single missing semicolon could absolutely ruin your entire week. But what if you never had to write a single line of syntax ever again? Today in this explainer, we're exploring an incredible transition from the absolute grind of manual code writing to what's known as intent expression. Welcome to the highly anticipated era of self-assembling software.
Here's a quick roadmap of what we'll be exploring today. We'll start with the end of manual coding, then peek under the hood at how software actually builds itself. After that, we'll map out your entirely new developer workflow, uncover the global ripple effect across industries, and finally, we'll shine a light on some severe, hidden security risks. Let's get right to it.
Section 1. The end of manual coding. Moving from syntax to desire.
In the traditional programming world, you face constant, maddening friction. You're writing hyper-detailed instructions in languages like Python or Java, constantly battling syntax bugs, basically acting as a manual translator between human thought and machine execution. It's exhausting, but in our new reality of intent expression, you don't write code at all. You simply state your desired outcomes, your goals, and your constraints using everyday natural language or visual diagrams. You just tell the computer exactly what you want it to do.
Now, what's really interesting about this slide is the core engine driving this entire shift, self-assembling software. So what does that actually mean in practice? It means we have artificial intelligence systems that automatically locate, connect, test, and deploy precise code modules based entirely on your stated requirements. The software literally compiles itself from the ground up. No human middleman required.
And this shift achieves some absolutely massive objectives. First off, it removes technical barriers. You no longer need to stress over configuring databases or managing memory. Second, it accelerates development to a staggering degree. We're talking about dropping the time between a raw idea and a fully working application from months down to mere seconds. That's a total game changer. It drastically lowers production costs and it enables continuous adaptation. So if your business goals change tomorrow, no problem. The software automatically rebuilds itself to match the new reality.
Moving on to Section 2, how software builds itself. Let's look at the AI pipeline.
I want you to think of this automated pipeline as a high-speed, perfectly synchronized relay race. Step 1 is intent capture, where the interface takes in your text or voice requirements. The baton is then instantly passed to Step 2, semantic parsing, where advanced AI parses your words to determine the exact logic needed. In Step 3, component retrieval, the system dives into this massive library to grab verified code blocks. Step 4 is assembly and integration. This is where the AI actually writes the glue code, connecting all these pieces together. Step 5 is automated testing, running the newly assembled software through simulated environments to catch any bugs. And finally, Step 6, deployment. Boom! It is a flawless, high-speed sprint from idea to instant execution. Now, the success of that entire pipeline relies heavily on a perfect marriage of technologies. You have the intent expression interface meeting large reasoning models, or LRMs. These are advanced AI engines that truly deeply understand human context, and they're deeply connected to massive, secure repositories containing millions of standardized, verified code modules. It's that combination that makes the magic happen.
All right, Section 3, your new developer workflow, stating desires.
Let's walk through a typical day in this new paradigm. Decision-making now flows entirely chronologically. Step 1, identify the problem. Let's say you need an automated inventory tracker. Step 2, formulate the intent. You lay out clear rules and success metrics. Step 3, review the system's generated conceptual blueprint. Make sure it understands you. Step 4, evaluate the output against your intent by running real-world scenarios. And Step 5, refine the specification if needed. Now, notice what's entirely missing from that list? Yeah, you never opened a code editor, not once. You've shifted from being a coder to being a domain expert.
I want to really emphasize this next quote because it represents the ultimate paradigm shift. If this software requires changes, you do not edit code. You alter your written instructions and the system rebuilds the application. Let that sink in for a second. Human precision in language, your ability to clearly, concisely articulate exactly what you want, is now the single most critical programming skill you can possess.
This brings us to Section 4, the global ripple effect. Let's talk practical implications.
So the crucial point is how fundamentally this reshapes the "what's in it for me" for almost every role out there. For businesses, you can launch full digital products in days, testing markets with almost zero risk. For IT departments, the veterans get to shift away from fighting tangled legacy code bases to simply monitoring system safety and compliance. Individual users, you can suddenly build custom tools tailored to your exact daily workflows. And product managers can translate customer feedback directly into immediate software updates, just by tweaking the intent instructions. It's wild.
All of this creates a profound impact chain. Thanks to instant deployment, we are witnessing a true democratization of creation. Non-technical workers can now completely bypass those traditional months-long IT queues to build their own solutions. Meanwhile, and this is important, human software engineers aren't going away. Instead, we're seeing a massive resource reallocation. Engineers will pivot completely away from fixing minor syntax bugs to focus entirely on high-level system design, security architecture, and ethics.
But it's not all sunshine and rainbows. Section 5. The hidden security risks. The price of automation.
The most pressing risk highlighted in the source material is something called the alignment problem. Basically, if your written instructions are even a little bit vague or inaccurate, the system will build software that functions flawlessly but achieves the totally wrong outcome. Think of it like a genie in a bottle, or, the classic monkey's paw story. The AI will grant your wish exactly as you requested it, but if you aren't perfectly precise, what you literally asked for might be disastrously different from what you actually intended.
And we absolutely must impartially report on the other remaining limitations here because giving up granular control has a price. There are hidden vulnerabilities to consider. I mean, if a component in the registry has a defect, your self-assembled software inherits that defect automatically. Then there's the very real threat of vendor lock-in to whatever specific AI platform you're relying on. You also face a loss of granular hardware control. It's really tough to optimize software for niche hardware when you don't actually write the underlying code. And finally, audit difficulties. Reviewing millions of lines of self-assembled code for regulatory compliance, it requires highly specialized automated tools because human review is simply far too slow to keep up with machine speed generation.
Which leads us to our final provocative thought for this explainer. As we completely remove the friction of coding, we have to stop and ask, when the software builds itself, who is really in control? Is it you or the machine? It's a heavy question for you to ponder as we step into this frictionless future. Thanks for joining me to explore the era of self-assembling software. Keep learning, keep expressing your intent clearly, and I will see you next time.